My friends, welcome to this week's weekend special. In this week, I will be working on Model Mania 2014. This comes with two different phases. Whereas phase 1, I'll have to build this. Again, it's probably something that goes on the shaft and then goes up and down. So kind of clamp with 3 holding parts. On the phase 2, it changes to 2 holding part and 1 still 3 three holding parts, but 1 would switch the plane. So these phase 1 and phase 2, I do not think I'll be able to do it via any configuration table. However, we will be starting with phase 1 and see how far we can go in part 1. If it goes too long, I will split this video in part 2 as well. So with that, let's go ahead and start working on this model. I definitely can keep these in the background to help me in the sketching process. So first thing is to check the accuracy or the calibration of this model, which seems like we will have to do it. So after the calibration, I want to make this half transparent, 50%. That's very important for the next step. And obviously I want to keep it on XY plane for this one. And then with keyboard shortcut AC, show the axis cross. So this is the center of the sketch that we'll be drawing. I want this image to move to the center of the sketch. And I feel like this would be better. So I'll just go ahead and mesh the center. It's almost there. Yes. And then I will be using these dimensions as well. So let's take the axis cross away. We are done with axis cross and start sketching. At this point, I should probably update my FreeCAD version 2.22 DB. So I'm using the 0.22 developers version, and there it is. I updated my notification part. So this version is still unstable. So we will see how far we can go with this. If it becomes an issue, we'll switch back to 0.21.2 version. All right, our sketching involves a circle. So that's GC, and the radius of that circle will be 25. Okay, and then it involves another circle, but this time it would be construction geometry. So that's GN, and this radius is 75 divided by 2. And then we have 3 more regular circles here. The radius is 5, and we'll just, on this one, I'll just draw the circle and then make them equality constraint with the first one. Okay, now let's place this on this circle. So what? Okay, that's our constraint. So this is already on this perimeter I already drew. So let's take this and select on the axis, hit C on the keyboard. That's shortcut for coincident constraint. So there's the new shortcuts that comes up with 0.22, and really like it. So this is already on the circle, and this is already on the circle. Although I'll have to constrain them, I'm gonna go ahead and then place them vertically. So that's P on the keyboard, and then all I have to do is make an angle here. So easiest way to do it is make a construction line just like that, and say this line is at, I think it's 60 degree, because the gap between these two should be 120, because we have three of such lines around a circle. All right, so far so good. We are doing good progress. Let's make this solid geometry and then take this arc. Now the next part, I should probably take the polyline. So I'll start from here and see, yes, there, and I'm just keeping MMM pressed. See there, it's not helping me. So this, okay, we'll just keep going and then come back to fix them later on. Yeah, I think between 0.21 and 0.22, something changed between the polylines, and I don't find polyline that much useful in 0.22 especially. I don't know why, but it looks like something changed. The polyline at 0.21 is much better performing, but hopefully the stable version, when it comes out, somebody will realize from the developer side that 0.21 has better polylines than 0.22. Okay, so first of all, I want to go ahead and make all of these three equal. So select all of those, hit E on the keyboard, and then take this and make it coincident. So that's C. Now that is fixed. I probably want to do that on here too, and here. Okay. The next, let's fix the dimension to it. So that dimension is going to be 8. Okay, so that part is done. Now we can go ahead and select these 6 arcs and make them equal. Okay, looks weird, right? And maybe a good time to put a dimension on that one, which is 8, so probably equal to this. Okay, and then how about we take this, so this is the center of this arc, and place it in the center, maybe this one too. Let's see which one. Yes, so this one will go there too, and this one will come. And okay, so we got this coming down to a good shape. Here I think it's a good time to actually place a tangential constraint, and there. Okay, we have 10 degrees of freedom, maybe 3 degrees of freedom times 3, so 4 degrees of freedom actually. Okay, so this is moving erratically, so we want to go and make all these 3 equal, and then see that one is radius 30, so put some value on there that will actually constrain it, so it's less moving now. Now we have 7 degrees of freedom, and I know what it is. The angle between these two would be 30 degree. What it means is the angle between these two is 15, and the angle between these two is another 15. Right, and then there will be a tangency between these two parts. So now that we have that part sorted out, how about I take these, two, right, and make it symmetric by this axis. Okay, so this is still moving, and I'm gonna go ahead and make these 30 degrees, and so will be these two. Okay, that kinda, this is still moving. Maybe I want to make these two equal. Yes, so that's a fully constrained sketch, which is the base sketch we want. I'm gonna go ahead and rename that. Okay, and I want to extrude that for 20 millimeter right now, and maybe make it symmetric. So this is going half and half, up and bottom. All right, now let's talk about these gaps that we have. So we'll have to have 3 gaps, one here, one here, one there, one. So one under each of these holders. And maybe now I should take a look at phase 2. So between phase 1 and phase 2, I can see where these two parts are staying almost same. These gaps here, it is spanning only this part, so equally distributed over 3 holders. On phase 2, that gap, so this part stays fixed, this part, and that gap becomes a bit bigger on this side, and there is no gap on this. So phase 2 and phase 1, I see these two gaps I can retain, but it will be elongated. With that thought, let's see how we can make that gap. So this looks like, from this image, it's look like a slot. I know, slot on a curved surface, and but this line says it is going straight horizontal, so there is no angular dimension on the top and bottom side. On the side, it's kind of expanding, and the easiest way, I think, is to actually make it really simple to manipulate. So I want to rename this as base, right? And then hide it for now. What I want to do, I want to draw a contraption. So let's go to new sketch, keep it on XY plane. Let's see, what if I made something like this, right? And okay, so it will have to be really big, something like this, that matches with this line with an angle of, okay, so we'll think about the angle. Maybe I want to make it radial, so take this point and put it on that line, so that makes it radial. See, if it moves, it will moving in a radial fashion. I want to make this one radial too, so this moves this way, because we'll need to move this round. Not this one though, this will be fixed. That looks like a 15-degree angle, so if we keep it fixed, and maybe make these two kinda, so this distance, how about 20? Okay, we keep it there, so now it will be moving just like that. So it will be here, and then it will move there. Okay, that idea is working. I want to go bring it up all the way there. Now let's go ahead and make an angle. So if this is half of this is 45, I'm thinking the angle between these two will be 90. Okay, now what if I make this 90 something big, the 110? So that moves, so it will come handy in our phase 2. Okay, and then I want to make these two equal, and I want to keep it, okay, let's bring it over here, say 120. Yeah, and then I want to have this line at least outside of this boundary. With that, let's see how far we are going. So this is 72. Yeah, 75 is a good number, and let's bring it back to 90. I am doing this so I can have that slot drawn. So I'm going to go ahead and make this new construction geometry. So when I actually finally close it out, so this is our, I'm going to say, datum planes. So these are my two datum lines that I can go ahead and extrude that for, say, 50, doesn't matter, maybe both ways. And there, so I have two datum planes. Now this plane is actually pulling data from our sketch, and I can go in there and find that 90 degree. I can make that 120 easily. So that kind of where the idea is. Okay, on this one now I want to go ahead and draw a sketch on that face, and I want to take reference of this line and this line, and between these two I want to draw a slot of, I don't know what was the radius. I think the radius was 6. Okay, cool. Now I want to take these two and make them tangent to each other. Take these two tangent to each other, and that's a full size. This length we didn't have to worry about it. Whatever these two lines goes, the slot will be in between them. Okay, let's see if that theory is working. I go to datum plane sketch, make this 120. Yes, so the slot is expanding, and that's all we need. All right, another one on this face, the same thing. So there will be a slot of 6 millimeter. Remember, because this line, the horizontal line doesn't change. I want to take this line as my reference and this one, and take the reference line, make them tangent to each other. Do the same on this side. There it is. So we have two slots. So I'm gonna say slot 1, that's the sketch. I don't think I'll have to come back to this to update anything even in the phase 2, but we have it here. So these two slots, I can go ahead and make a loft between these two. I'm going to create a solid, and okay, so there is our slot. I'm going to go ahead and hide the datum plane right now. So, and then, so this is the sketch datum plane. Let's bring back our main base and make a cut. So take this one, take this one out of it, and there it is. That is our first gap. We got that. So for phase 1 and phase 2 going forward of this, there will be two different methods. So now probably it's good time to save it as a phase 1. We got our phase 1 almost there. All I have to do is take this cut, or like not that one, maybe delete that cut, and take this loft, make an array of 3, and maybe fuse it. Okay, so now we have 3 of these cutting pieces. I want to make a deduction from the base of this object, but I don't know if I'll have to make it a compound yet. Let's give it a try without making it a compound. Yes, it worked. So now that's our phase 1. To be honest, this is phase 1. Okay, we got our phase 1 built. Very simple, we did that. And now transitioning to phase 2, we have to update few things. So we'll have to take care of this part first. So base sketch will be changed, and then we'll have to update the cutting tools. Okay, so let's save it as phase 2 and delete this cut now. Maybe delete the array too. Since I was working on this loft recently, fresh memory, I'm going to go ahead and take care of that first. What I want to do, I want to take the loft and mirror it. I want to mirror it against XZ plane. Okay, what it does is it gives me two cutting surfaces right there. So these two will be my cutting tools. So here it has two gaps, and I have those already there. So once I'm ready, I can make a cut, I'll have those two gaps, but I'm not ready yet. So let's go back one step and hide these fusions. So go ahead and rename that as cutting tools. Right now I want to put my focus on this base sketch. We know that this part will have to change, so let's delete that extrude, bring that sketch back, and maybe make this part. So take all of these, right, and make that construction geometry, so that part won't show up in our extrusion. And take an arc by center and connect between these two. So I want to place it on this point, that is C on the keyboard, and place on this arc maybe. Yeah, that's too much. Okay, let's do something else. How about I bring it up and then make these 2 points coincident? Yeah, that's better. All right, so now we have this, and extrude that for 20 millimeter both ways. So we have phase 2, this part built. On this side, it will be another sketch on XZ plane. So let's go ahead and do a sketch on XZ plane. So I don't want to attach it, I just want to do it on XZ plane. Okay, on this one, so that sketch will actually be simple rectangle to begin with, something like this. Now this point, I want to bring it inside somewhere here, so it is crossing somewhere here. So let's say that line would be, I'm gonna say 20. We may have to come back to this 20 in a minute, but let's keep it in our mind that we want to bring this line inside of this tube. And then I want to delete this part and draw an arc between these two. Okay, since I drew the arc with the center on this axis, these two lines are already symmetric, so I don't have to make them symmetric anymore. All I have to do is specify a dimension to this, and I think this will be 10. So that kind of matches with our object. Okay, the only thing I need to worry about is how far this center should be, and maybe I have to make them tangential. Okay, so this distance will come from the technical drawing, which is given as 40. Okay, so that is our sketch for phase 2 rotated holder. I'm gonna go ahead and sketch phase 2 rotated end. Okay, and then I want to extrude that for a length of, okay, that will come from the technical drawing as well, which comes as 12. I want to make it symmetric by the axis, and there it is. Now, well, I should have gotten that center hole embedded in there. So let's go back and do a circle centering here with a radius of 4. Okay, now I want to go ahead and take care of this extended portion, and that would be taking these two and make a connect object. So under here is connect object, and that takes care of it. As long as, okay, now there is a big if, as long as this part, this inside part, is smaller than a hypothetical divide. If you divide this object here, this part should be smaller than this part, so that way it will be eaten away. Otherwise it will not work. It will keep the inside, delete the outside. All right, we got this. The only thing left is to do a saw cut, and that would be another sketch on XY plane. Okay, so sketch on XY plane, not attached to anything, and draw a simple rectangle, something like this. Give it a dimension of say 60, and then width will be, this will come from the technical drawing, which comes as 2, right? And then maybe these two will be symmetric by the axis. So that's S on the keyboard, and I want to place these on this axis. All right, now this is a saw cut, so it will go up and down. Let's say get saw cut and extrude that for, say, I don't know, and extrude that for 50, I guess. Okay, make it symmetric, and all it matters is that it should go up and down, covering the cut that will be performing on the object. So take this object and take the saw cut, make a boolean cut. So there it is. That is exactly what we are looking for. Yes, so we have phase 2 almost there. All I have to do is bring back these cutting tools and make a cut. Well, we'll have to go into the cutting tool and into the loft, into the sketch. So not that one. Actually, we won't have to do from there. We'll have to do it from this sketch. Remember the datum plane? That's where we'll have to go in and make this 120. And that magically extends our cutting tool, makes it bigger, and eats away everything that we needed to eat away. All right, so as you can see, this angle is 120. So that's what it was 90 previously. In phase 1, this angle was 90 between this line and this line. Now it is 120. So that's what we changed, and we get our phase 2. Perfect. I'm so happy that phase 2 or phase 1 does well. Phase 2 has a fillet on here. I was so happy that I didn't have to deal with any fillet, but it does have a fillet, and it should be easy. So take these two and make a fillet of 8mm radius. Should not be any problem for this one. This is easy fillet. All right, we got our phase 2 build. Let's make that phase 2, and then save it. Okay, building part is done. Then there is something else too. The model asks for a FEM analysis, so we'll have to fix this point and then apply 1000 total load to these 4 faces. So what it means is I'll have to pick all of these and then apply 250 Newton at each of these locations. Well, if we have to do it, we better start doing it as soon as we can. So let's go to a FEM workbench and give it a minute. And start with an analysis container. It should have a solver already in there. If it is not already in there, just add a solver from the toolbar right here. All right, and then comes the material. The challenge asks for AISI 1020 material. Okay, let's see what AISI 1020 stands for. It says low carbon, low tensile steel, and that one has a tensile strength, yield strength of 300 MPa. So we'll have to pick a steel that has 300 MPa of tensile strength, yield strength, not the ultimate. We don't care about ultimate. All I care about is yield strength. I mean, we do care about ultimate in situations, but on this case, 300 MPa of yield strength is all we need. So we'll go find steel. And say 1C60 and see what is the yield strength of this material is. So the yield strength is 380 MPa, more than what we need. So we probably go 1C22. The yield strength is, that's too less, maybe halfway there. This will do. So 1C35 is what we need. So that's our material. And then I want to go ahead and fix these two surfaces, this one and this one. Okay, now loading part. I want to go ahead and apply. So add this. I want to pick. Okay, so I probably want to pick this one as well. And then take this add option off by clicking on it, and then select this line, so which is going downward or like upward, and then hit direction. So that brings it downwards. If we wanted to have this load applied upwards, we would just say reverse direction. It will come upward, but downward is fine with me. On here, I want to say 500 Newton. Now, one thing, I don't know if it will affect that. Yeah, let's go ahead and see how it plays out. So we will do the same thing on here, on this face and this face, and select this line and direction. Okay, the load magnitude is 200, actually 500 Newton, and that's it. So we have the support, load, material, and solver. All we need is a mesh. So I'm gonna go with G mesh with first order, see if it works out. It did. It took only 5 seconds and then it did work out. Okay, so let's go back to the solver, double click on it, and write the INP file and hit run calculix. And again, give it a minute. So it didn't take long, only 6 seconds of analysis time, and we have our results. So let's take a look at it. I want to go ahead and hide this and double click on the CCX results, see what the displacement looks like. So we'll have 0.27 millimeters of displacement, and let's take a look how it plays out. I want to apply a 10 factors of magnitude and see. Okay, so this is moving all together. Looks like because the whole thing is moving all together. I mean, I think it would be okay if we selected all 4 faces and applied 1000 Newton load on this, and it would still have the same loading pattern, same deformation pattern. All right, so we have 300 MPa of stress developed, and most of them stress is coming at this corner and this corner. So here, so if we apply like couple more hundreds of newtons of load, this object will technically fail. So it will not break because the rupture ultimate stress is higher than that. Ultimate stress is like 400 MPa. So it will probably stay, but it will start yielding. So you will see the deformation towards failure after 1000 Newton load. I hope you enjoyed the model building and the FEM analysis of this model. Thank you for watching. If you have any question, comment, or suggestion, please leave them below in the comment section. and I will see you in one of my next videos.